So hello everyone. Today we are going to discuss the problem from the latest weekly round of Leetcode. Count the number of complete components. So in this question, what you have to do, you are given a integer n and there is a undirected graph of n vertices numbered from 0 to n minus 1, and you have to give you are given a 2D integer array as is, where as is I denotes ai comma bi, which denotes that there exists an undirected s between ai and bi. So you have to return the number of complete connected components of the graph. A connected component is a subgraph of a graph in which there exists a path between any two vertices, and no vertices of the subgraph shares an edge with the vertex outside the subgraph. And a connected component is said to be complete if there exists an edge between every pair of vertices. So let's abstract the information from uh, what is a connected component, what is a complete graph, right? So a connected component is like you have given a graph like this. So let us say you having you having five vertices, and there are three edges. So what is a connected component means a from connected component means a component in which should be a path from between any two vertices. So let us say from one you have to go to two, so you can go to two, right? But from one, if you have to go to zero, you can't go. So this is a connected component, and this is a connected component. These both are not connected component because from these three you can't go to four. This four. So a connected component is a component in which from between any two vertices there should be a path. Means from any two vertices in this you can go from one vertex to another. But in uh, this situation you can't go to four from one or two or three. So that's why there are two different connected components. So there are two connected components. This is a connected component, this is a connected component, right? And talking about a complete graph, let us say this is a graph. So if between a complete graph is a graph in which between every two vertex there should be a edge. Let us, in this is a complete graph. Why? Because from one you can go to two, from one you can go to four, from one you can go to three. Similarly, from two you can go to one, and from two you can go to three, and from two you can go to four. So means what is a complete graph? Complete graph is a graph in which from every vertex you can go to any other vertex. Means there should be edge between every pair of vertices, right? From one you can go to two, from one you can directly go to three, because there should be edge between one and three. So a complete graph is a graph in which between every two vertices there should be a edge, right? So I hope you I have done with the complete graph and what is a connected component. So we are in this question we have to find the number of complete components. Means we have to find complete components. Means we have to check for a given component is complete as well as connected, right? So let's uh, take the example. So So let's take this as an example, right? So yeah, so let us say for this example, for the question, given question, let's check. So this is a, so we have to return the how many connected components, complete connected components, right? So let's give numbering this one. Let us say this is 2, this is 3, this is 0, this is 4, and this is 5. So we have to find the complete components. So let's check this one. So this is a component, because uh, from 1 we can traverse to 1, and this is complete as well because there is only one vertex in this. So let's talking about this component. This is a component from 2 we can go to 3, and from 3 we can go to 2, and this is complete as well because from 2 there should be a direct as to 3, and from 3 there should be a direct as to 2. So this is complete as well connected. So till now we having two complete connected components, this and this, and checking now we have to check this. So from this from this is a component because from 0 you can traverse to 4 and 5, and from 4 you can traverse to 0 or 5. So means between every pair of two vertices there should be a path. So this is connected, and for checking to complete, from 0 you can direct there should be s to 4, from 0 there should be s to 5, and similarly from 4 there should be s to 5 as well as vice versa, because from 5 there should be s, and from 4 there should be s to 0, and so that's why between every pair of two vertices there should be s. So that's why this is uh, also complete. So there are three, so there are total three complete connected components. So how can we approach this? We so basically we check first, we check the connected components, and then we check the connected components. So how we check the connected components? We basically run a DFS from, let us say we run a DFS from 0. So when we run a depth first search from 0, so from when we perform a DFS from 0, let us say we perform a DFS from 0. So in my temporary area, I store this from 0 we can go to 4, and from 4 we can go to 5. So this is a temporary, this is a temporary array in which we store the DFS from 0. So from this would be the DFS from 0, and we traverse all 4 and 5. So this is a temporary array. Now this gives me a connected components, means we having a connected components. Now checking for the whether this is complete graph or not. So from to check whether this is complete or not, we store the out degrees of every vertex in a we pre-compute the out degrees of every vertex, right, in an array. So for the out degree of 0, out degree of 0, it is 2, and the out degree of 4, it is also 2, and the out degree of 5 is 2. So this is complete as well because the out degree of the every out degree of every node is equals to 2. So that's why this is complete as well. For from checking for now, we do a DFS for similarly for 1. So this is uh, its out degree 0, and uh, out degree 0. So this is complete, and we check for the 2 and 3, run a DFS for 2 and 3, and store 2 and 3 in a temporary array, right? And check the out degrees of 2 and 3. So the out degrees of 2 and 3 is 1. So both having out degree equals to 1. So this is also a complete graph. So that's why we found with three connected components. So basically we just run a DFS for a given node if it is not visited, and then we check the out degrees of all the all the nodes in that, right? So yeah, let's move to the uh, code part of this implementation of this problem, where I hope you understand more. So let's see. So the code for this problem is like, first we create a graph from the given asses and create a visited array, right? And store a count which is initialized with 0. So and then I run a loop from 0 to n, which uh, for which is for every node, and we check if the node is not visited, then I run a dfs from this node, and I store so that in this dfs I store the number of nodes in the temporary array which is global. So I store the number of nodes in this temporary array, and then for I check, I store the size of the temporary array, and for every node inside the temporary array I check the out degrees of that. So if the node having out degree not equals to the size of the array, then I just make the test equals to 0. And if all the nodes having the out degree equals to x minus 1, means the size minus 1, then I increase the counter. And finally I clear the temp, because in every go I store temporary uh, nodes of a component, right? From a different component, and finally I return the count. So this is it for this video, and I hope uh, you are done with the connected components and you are done with the complete graph, and the implementation should be clear to you all. So thank you, and subscribe to our channel for more such videos.